This is Bob Cup, and this lesson is on odds and probability. Let's just kind of get a basic idea of how this works. I want you to imagine there are 3 cards on a table, and the game is for you to choose the winning card. So let's say this is the winning card, and these are 2 losing cards. We have 1 winning card and we have 2 losing cards. So assuming these are upside down and you don't know which is which, your odds in favor are what? Odds in favor. I'm choosing 1 winning card to 2 losing cards. And your odds against are 2 losing cards and 1 winning card. So this is the notation that we're most used to seeing. Of course, most mathematics textbooks prefer to express these ratios as fractions. So 1 to 2, 2 to 1 that way. That is in essence what it means. Now, I just want to give you a warning. There is a standard con game that is played called 3-card Monte. Never play that if you find yourself in a city where someone is trying to hustle. That game is easily fixed by the gentleman that is dealing the cards. So do some research and you'll see not a real good idea to do that. So what's our probability of winning this game? If we're just choosing one at random, we have 1 winner out of 3 total. Our probability of winning is 1 in 3, and our probability of losing is 2 in 3. So this will give us an idea about how to connect these ideas in terms of odds and probability. So what are we going to say first? Again, so let's E be our event to choose the correct card. So not E, of course, would be choose the incorrect card. So we'll start with odds in favor. Generally speaking, here's our formula. The odds in favor are the ratio of the probability of E happening divided by the probability of not E. So connecting to our previous example, we had 3 cards to choose from. 1 out of 3 here, not E, 2 out of 3. 1 out of 3 divided by 2 out of 3, which of course is 1 out of 3 times 3/2 gives us 1 out of 2, or in the more standard notation here, 1 to 2. If we wanted to go ahead and rewrite this in terms of odds against, which frankly I think is more useful, odds against is sort of what they give you if you do parimutuel betting. Odds against is just the reciprocal of this fraction. Probability of not E divided by the probability of E. So in our case, 2/3 divided by 1/3, which gives us 2 to 1. However, if you go to a racetrack, that's the pay table. The pay table may be 2 to 1. That doesn't really mean that your horse has a 1 in 3 chance of winning. That's how they're choosing to pay you. And of course, a racetrack has to make money, so they're going to keep a good portion of that. So let's look at some examples here. Here's our experiment. There are 3 marbles in a bag that has 10 marbles total. We want to find the odds in favor first. So we're going to select 1 marble. We're going to find the odds in favor of selecting 3 red marbles. 3 red marbles in a bag of 10. Select 1 marble. Find the odds in favor of selecting a red marble. So here's our standard question. So the odds in favor, probability of E divided by probability of not E. So there are 3 marbles that are red in a bag of 10, so my chances of choosing a red marble are 3 in 10. Not choosing a red marble, 1 minus 3 out of 10. Again, complement rule. So we get 3 out of 10 divided by 7 out of 10. So what are our odds in favor going to be? Three out of 10 divided by 7 out of 10. 3 out of 10 times 10 over 7. 3 to 7 or 3 to 7. Now that shouldn't surprise you. What did we say was in the bag? 3 red marbles in a bag of 7, which means we have 3 red marbles. The total is 7. 7 non-red marbles. So there's how your odds reflect your probability. 3 good ones, 7 bad ones. 3 to 7 would be your odds in favor. The odds against, of course, would just be 7 to 3. Odds against in this case, just 7 to 3. Okay, let's take a look at another example. This time we're going to choose a card from our standard deck of 52. So that is our experiment. 1 card is selected from a deck of 52. Find the odds in favor of selecting a jack. So what do we have here? We need our probability. We need our event. So we'll call J is the event selecting a jack. Not J, of course, would be the event not selecting a jack. So the odds in favor of selecting a jack would be the probability of J divided by the probability of not J, or J complement if you prefer that notation. How many jacks do we have in a deck? 4 jacks out of 52. How many not jacks do we have? Well, the other 48 cards. 48 out of 52. And you can see that this reduces to 4 to 42. 4 to 48. First, which you could also think of as 4 over 48. Or 1 out of 12. So my odds in favor of selecting a jack are 1 to 12. The odds against, just the reciprocal of that, the odds against are probability of not J divided by J, probability of J. So 48 out of 52 divided by 4 out of 52. So we get 48 to 4, which is 12 to 1. You certainly don't want to just say 12. You always want to express odds in terms of a fraction. Frankly, I prefer the ratio form, but as a fraction, you can say that the odds against are 12 to 1, that you are going to select a jack. Let's take a look at another example. This time we're going to look at a raffle and how the number of tickets is going to change our odds. So 200 raffle tickets are sold. One grand prize winner will be selected. If a person buys 1 ticket, what are the odds in favor? Now let's think about this. How many good tickets to how many bad? There are 200 tickets sold. The person just buys one good ticket. He's got one good ticket, 199 bad tickets. So in terms of thinking about what this should be, 1 to 199 should be our model. Odds in favor, probability of winning divided by probability of not winning. Probability of winning 1 in 200 divided by the probability of not winning 1 minus 1 in 200. Again, 1 in 200 divided by 199 over 200, which gives us 1 over 199, or if you like, 1 to 199. The odds against, similarly, probability of not winning divided by the probability of winning, which will just be 199 to 1. Now, how does this change if we buy more tickets? Remember our odds, the number of winners divided by the number of not winners is a way to think about that. So if instead we buy 10 tickets, let's find our odds in favor. So again, 200 sold, you buy 10. 200 sold, buy 10. Let's let E be the event. 1 ticket wins. So the probability of E, the probability of winning, is 10 out of 200. We want the odds in favor. The odds in favor, probability of E divided by the probability of not E. So 10 out of 200 divided by 1 minus 10 out of 200. 10 out of 200 divided by 190 out of 200, which will become 10 over 190, 1 to 19, or 1 to 19. Would be my odds in favor, and then the odds against, just the reciprocal. The odds against would be 19 to 1. And again, the one time you'll see odds in the real world is in gambling. Pari-mutuel wagering for sure at a racetrack. You'll see that's how they're going to pay you, similar to the notion of the probability, but again, they keep a good portion for the house. So let's try to connect these ideas if we can. We make sense of this. So our basic idea is from the odds in favor, the odds in favor are the probability of the event happening, the probability of E divided by the probability of not E. Okay. But the probability of E, let's just say we call it A, the probability of not E might be 1 minus A. So that's something for us to think about. Now, how can we make sense of this? Well, let's say that our odds in favor are 3 to 7. What does that mean? That means there's 3 winning numbers and there's 7 losing numbers. So what is your probability? Okay, 3 winning, 7 losing. If that's the case, what is your probability of that event? Probability of your event, E. What will that be? I have 3 winning out of how many total? 3 over 3 plus 7, which is 3 over 10. Which in essence tells us how we can go from odds in favor to probability. So if the odds in favor are A to B, or if you like, A over B, A winners, B losers. So our total is A plus B, and we have A winners. If that's our case, what's our probability of E? A winners out of how many total? Out of A plus B total. So if odds in favor are A to B, the probability of winning, probability of that event, E, is just A, the winner, over the total, over A plus B. And that will conclude this lesson.